So this is Chapter 5, Section 6, Factoring Trinomials. And we're going to factor all kinds of trinomials, but our first objective is to factor trinomials of the form x squared plus bx plus c. These are called Monic Polynomials because the leading coefficient, that's the coefficient on the largest degree term, is 1. So there's two major classifications. There's all kinds of classifications of polynomials. Monomial, binomial, trinomial. Now I'm giving you two more. Those which can be factored and those which cannot be factored. And when we factor them into a product of two or more polynomials of lower degree. So one that cannot be factored into the product of two or more polynomials of lower degree is called prime or irreducible. And whatever method you use to factor polynomials will always produce a factorization if and only if one exists. So if a method does not work, and lots of times that means we've tried all possibilities and none work, then we can conclude only then that the polynomial is prime. And that's the case for lower level classes. There are tests to find out if polynomials are prime without doing hardly any factorization at all, but that will work for our class. We won't look at some of those advanced methods. Here is the homework hint. For your homework, not so much as your exam, this is really designed for the exam, the polynomials given to you are almost never prime. If there's any prime on the exam, there will only be one. Pretty much this is an exercise in learning how to factor. So let me talk about classification of degree 1 polynomials. So a degree 1 polynomial has the form ax plus b, where a and b are real numbers. And you may be anticipating a is not equal to 0. But we're actually going to be doing a subset of these. For our case, for us, a, of course, is not going to be equal to 0, and a and b will be integers. Remember, integers are positive and negative whole numbers and 0. For example, 7x minus 3 is a degree 1 polynomial. 121x plus 5 is a degree 1 polynomial. 21x minus 7, all of these are degree 1 polynomials. So this is number 1. It is a degree 1 polynomial. And why am I showing you this? It's because our factorizations will result usually into the product of two degree 1 polynomials. 2, if a is equal to 1, then the polynomial is called, I'll write this in a different color, monic. Now you will not encounter that in the text, but I might very well use it. It's a standard classification. Many times instead of calling it monic, they will just say the leading coefficient is 1. So that's another word to talk about that. And The third is the polynomial, so the degree 1. Sometimes these are called linear polynomials, and you should understand why. If instead of a there, I had an mx plus b, then you say, oh, that's one side of an equation for the line. So sometimes they're called linear polynomials. The degree 1 polynomial is prime. So that means it cannot be factored. That's also called irreducible. And here's our big statement: if and only if the GCF, in this case I'm referring to this one, A and B is equal to 1. So let's come over here and take a look at these polynomials. So let's look at 1. These are 2, 3, and 4. So I'll do x minus 5. So let's look at the GCF of 7 and 3. Well, these are both prime numbers, so immediately know that that's equal to 1. So by number 3, this is prime. Let's look at the GCF of 121 and 5. Now 5 is prime, so that suggests the answer is going to be 1, but we have to do one more check. Remember the correction I made last time? We have to make sure 121 is not divisible by 5. And it's not. It has remainder 1. So the GCF is 1. So number 2 is also prime. Let's look at the GCF of 21 and 7. So remember, the GCF of two numbers is always greater than or equal to 1, or less than or equal to the smallest of the two numbers. It's equal to the smallest of the two numbers if that number, the smaller of the two, evenly divides the larger. And 21 divided by 7 is equal to 3, so it's equal to 7. Now remember, those aren't the only two options. You have every number between 1 and the smallest of the two numbers is a possibility. So you just, sometimes there's an awful lot of possibilities for the GCF. So this one has a factorization. So this one can be factored. This one right here. And let's look at the GCF of 1 and 5. We just look at the positive. We don't look 1 and minus 5, just 1 and 5. Well, I already know the GCF is greater than or equal to 1 and less than or equal to the smallest of the two numbers. So that's 1. So I just discovered something. I'm going to go back and I'm going to factor number 3. But I just discovered another little fact I'm going to add to my list. If the degree 1 polynomial is monic. So remember, this is the reason I had you do a lot of definitions for that mathematical reasoning question. It all depends upon the definition. So if it's monic, it means the leading coefficient is 1. Then it is prime. So we found out of all of these, only one has a factorization. So let's figure out that factorization. So we have, and you should be able to do this on your own, we discovered that the GCF of 21 and 7 is 7. So I'll bring 7 out. Then 21x divided by 7 is 3x. Then minus 7 divided by 7 is minus 1. So I just factored it. I factored it into a degree 1 and then a degree 0 polynomial. This is a factorization. So with that in mind, let's go ahead and let's develop techniques to factor certain forms of trinomials. So this is a monic trinomial. Remember, monic just means the leading coefficient is 1. And I'm going to show you how I've done this. This seems to work really, really well, but there are many different ways to factor trinomials. And depending who taught you how to factor trinomials, if you've actually been taught how to factor trinomials, they may present a completely different way. So your job is to all of these different ways is just to choose one that you really like and stick to it. Now the one I'm going to present to you, I've chosen because students seem to understand it, and more importantly, they don't forget it. So pretty much we start out by drawing kind of like a tic-tac-toe board. And here's how we go. I probably should have, these two squares should be more or less evenly spaced, but it doesn't really matter. So let's look at our polynomial. So I'm going to do a few of these, and then I'm going to show you why it works. So x squared plus 10x plus 16. So what I do is I take these terms. The first term, x squared, I write here. But I don't go in order. I skip down to the very last constant term, and I write it right there. And I put the middle term in the last bucket, or the last little ledger place. And now what I do is our whole job will be to fill in these 4 slots right here. And we're going to be multiplying across this way. Then we're going to be multiplying down this way. And that's going to give us 2 little values right here and right here. And then we're going to add those 2 values. So let's just start. The best way is just to do it and continue on doing it. So the first thing I want to do is I have to put 2 terms, variable terms here, that when I multiply them together, they get me x squared. Since they have to be variable terms, I only have one choice. The leading coefficient is 1, and they have to be variable terms, so I put an x and an x there. So when I multiply, so these x's mean multiply, doesn't have anything to do with the unknown. When I multiply x times x, I get x squared. And I'm done with that first row. Down here, I have to put in 2 numbers such that when I multiply them together, I have to get 16. So 8 times 2 is 16, so I satisfied that. So now down here what I'm going to do is I'm going to multiply, I guess literally we can multiply up, but it's x times 8, which is the same as 8x. So this is 8x. 2 times x is 2x. And now, here's the important part. I got this little bubble and this little bubble by multiplying down, but now I'm going to add. This is the addition step. 8x plus 2x is 10x. So I have everything I need to factor. So how do I get the factorization of this polynomial from this table? Well, we draw kitty corner groupings. So remember, 2 is going to be positive 2 and 8 is going to be positive 8. And from those groupings, I fill in these two groupings because they're always going to be the product of two polynomials of degree less than 2. So this is x plus 2 and x plus 8. And I just factored this into the product of two linear polynomials. Well, let's check my factorization by using the FOIL method. X times x is x squared. X times 8 is 8x. 2 times x is 2x. And 2 times 8 is 16. And notice that the 8x here and the 2x here being added together give me my middle term above. And that's what I was looking for. And that's where you're seeing this right here. So I just factored x squared plus 10x plus 16. It is equal to x plus 2 and x plus 8. And the order of the factors does not matter. You should already know that when I'm multiplying two factors, x plus 2 and x plus 8, by the commutativity of multiplication, that's the same as x plus 8 times x plus 2. So it doesn't matter which one you choose first. I could have written x plus 8 times x plus 2. I just happened to write x plus 2 times x plus 8. So now you're kind of seeing what's going on. It's a really easy pattern. And the pattern, once you get it down, the reason I'm having you all do this is because I use this too, and I can factor things faster. Much faster than other methods. And there are at least two other methods besides this. So here I take so I'm going to factor x squared minus 12x plus 35. So I take my x squared term and I write it there. Then I jump down to the constant term. It comes second. And then the middle term comes last. Each one of these should be brought over with their sign. Now the minus 12 is the only thing we have to worry about writing the sign for, and that's because if I don't have a sign written in front of a number, it's considered to be plus. So again, I have to write two variable terms in my first row. When I multiply them together, I get x squared. So I only have one choice, x and x. So when it's a monic polynomial, meaning again that the leading coefficient is 1, then I can immediately write x and x. You never write negative x times negative x. That would work, but that's not what we want. We always want the factorization, the leading term in our factorization, to be positive. So now down here, I have to find two numbers. When I multiply them together, I get 35. And then when I multiply down, I get something here in a box, which I add to something down here in the box. So once I fill out this row, I'm going to multiply. Say this was 7, so that would be 7x. And if this were 5, 7 times 5 is 35, that would be 5x. But when I add them together, I have to get minus 12x. So that's going to cause some thinking. This is positive, and this is negative. So the only way I'm going to be able to get a negative when I add these two products together is to use a minus 7, for example, and a minus 5. So minus 7 times minus 5 is plus 35. And x times x is x squared. So now let's do the multiplication downward. That's minus 7x and minus 5x. So minus 7x plus minus 5x is equal to minus 12x. And I have my factorization. Now you don't have to draw these grouping symbols, but it's important that you understand that you're not grabbing x in minus 7 and x in minus 5, you're going kitty corner. So that gives me x minus 5 times x minus 7. Now I am making, so these two are equal. So I am making this seem really easy. And this is sometimes called a guess and check method. And some mathematicians don't like the guess and check method, but every last method involves some form of a guess. But it's not a wild guess. It's a guess that is constrained by the possible integers that I can multiply together to get the 35. And this is always for the Monic polynomial case, all of the guessing, if it occurs in trying to find out what you put in the second row. Now when we move on to the next case, it gets one little bit harder. We will also get guessing possibilities in the first row. So the more you do of these, the better you get. And here a warning: factorization skills are a necessity to complete this class. So it's really important that you do a lot of these problems. So let's look at the next one. Actually, I'm going to challenge you while I'm looking ahead not to do this one. I'm going to challenge you to do the number 4, because this next one is an important example. So again, I kind of make my little, you can call it your tic-tac-toe board, whatever. It's nothing really formal, but you need something that kind of looks like that. And from the actual problem, I'm factoring x squared minus 2x plus 16. So it's monic. So I put my x squared here, my constant term here, and my middle term at the end together with its sign. Now I already know that this first row has to be x times x. So again, multiplying across, x times x gives me x squared. Now down here, I have to come up with two numbers whose result is a positive number, but when I multiply those two numbers with x and add them, it gives me a negative. So both factors have to be negative. So 16 divided by 2 gives me 8. Well, let's look at all of the possibilities we have. We have minus 1 times, I guess I can use that for the times, minus 16. That's one possibility. Minus 2 times minus 8. That's another possibility. And minus 4 times minus 4. That's another possibility. And that's it. Because the next one I would do is I would have to go up. I'd have to have minus 8 times minus 2. But I already have that possibility right here. Minus 2 times minus 8 is no different than minus 8 times minus 2, except in the order. And since this is a monic polynomial, we don't have to worry about it. So let's try them. Minus 1 and minus 16. So that gives me minus x minus 16x. And that, when I add them together, it gives me minus 17x. And that's not what I want. I want minus 2x. So I have to try another possibility. Turning off all of that sound. Sorry, I thought I'd already done so. So I've got to erase it and try another one. I've tried that possibility. It doesn't work. So now let's try minus 2 and minus 8. So minus 2 times minus 8 gives me plus 16. Minus 2x minus 8x gives me minus 10x. And I want minus 2x. So that possibility fails as well. So let's erase it and try something else. Remember, my minus 8 times minus 2 is the same as my minus 2 times minus 8 when the case is monic. So literally I only have one more left to go. No, I didn't do enough erasing. Let me get this one and this one. So let's do minus 4 times minus 4. So minus 4 times minus 4 is plus 16. That gives me minus 4x minus 4x. That gives me minus 8x. So that didn't work either. So we conclude that nothing worked, and we were very thorough. So we conclude something that's really important, that this polynomial is prime, or if you prefer, irreducible. If you're thinking about being a math major, keep irreducible in your back pocket, and I'm pretty sure your text always uses the term prime. Okay. So let's try another one. So we discovered that that one was prime. So try to do this one on your own. It's really important that you try to do these on your own. There we go. So go ahead and write that down and pause the video and try it. So again, this is a monic polynomial, so I have no choice but to put x and x there. Here again, we have a negative middle term and a positive constant term. That means whatever I choose for 27, I have to put both negatives here. So 27 is equal to minus 3 times minus 9, and that's it as far as that goes. In non-trivial factors, 27 minus 27 times 1, and that's the factorization we have to consider. So let's try the obvious one, and this is a time symbol there. If you want, I can make it a dot. I'm multiplying those two. So let's try minus 3 and minus 9. So minus 3 times minus 9 is plus 27. So this gives me minus 3x minus 9x. And minus 3x minus 9x is minus 12x. So I get the factorization. So how do I know I'm done? Because when I multiply across, I get x squared. When I multiply across, I get 27. When I add, I get minus 12. So this is equal to x squared minus 12x plus 27 is equal to x minus 9 times x minus 3. So here we have 2. We just do an awful lot of examples. The more examples you see, the better you get at doing it. And again, especially for monic polynomials, that's leading coefficient is 1. There's many different ways to do these. And one particular way works really, really well. And the reason I'm showing you this method is because when we leave the world of monic polynomials, then you will see how much nicer this table is. So again, it's monic degree 1. It's a monic degree 2 polynomial. That means the leading coefficient is 1. You know, 17, I only have two choices. 17 is prime. So that's equal to 1 times 17. I use parentheses, so there can be, or minus 1 times minus 17. Since I want 16x, then I'm going to use 1 and 17. Well, that's x plus 17x. That gives me 18x. So that doesn't work. No go. And if I use minus 1 and minus 17, I would get a minus 18x. No go. So this polynomial is prime. Let's do the other one next to it. X squared minus 18x plus 17. So for instructors who teach the guess and check method, this is equivalent to the guess and check method. The only difference is that I arrange things a little bit differently. I make this little table over here, and most people just make you use FOIL and try to figure it out that way. So again, it's a monic polynomial. That means leading coefficient 1. Makes it really easy to figure out the first row. X times x is x squared. In 17, we just realized has two factorizations, and I'm using what we just did. So x times minus 17 is minus 17x, and x times minus 1 is minus x. Minus 17x minus x is minus 18x. So all three are satisfied. X times x is x squared, check. Minus 17 times minus 1 is 17, check. Minus 17x minus x is minus 18x, check. So I have the factorization now of x minus 1 times x minus 17. So now we're going to kind of throw a little bit of a curveball at you. We're looking at non-monic polynomials of the form ax squared plus bx plus c, where a is not equal to 1. But really, we're not going to have to do anything much, except we have to do one new step. we have to add one new step. And sometimes you will forget to do that. Sometimes I forget to do it. But our first step is always going to be factor out the GCF of all three terms. But I'm not done if the GCF is not 0. Now, if you forget to do that, what you're going to have will be a polynomial with non-prime linear factors. And if you caught that, you could just factor them at that point. But by factoring out the GCF, first, it makes the factorization easier. So let's look at the GCF. Since these are trinomials, all we have to do is take the GCF of all three numerical terms, numerical coefficients. 2's prime, 11's prime, done. It's equal to 1. So I don't have anything to do. I just have to go about factoring. So let's make my little factor table. And this is going to have one slight modification to it. But other than that, it's going to be pretty much exactly the same as before. So this is going to be now 2x squared. And then that's going to be 15. And that's going to be 11x. So the same order. But now you notice I have two possibilities. Well, we'll just say one possibility in this case because 2 is prime. So both of these have to be variable terms. There has to be an x in this box and an x in this box. So I'm going to put x in 2x. And that's the only combination because the leading coefficient is prime. So x times 2x is 2x squared. Now watch how that changes things. 15, the obvious factorization of 15, especially since 11x is positive, is 3 and 5. So that's going to give me 3x plus 10x. And 3x plus 10x is 13x. And that's not what we want. But I'm not done. I can still use those factors. I have to check one other thing. I have to check something else. Let's check 5, a different order. So that gives me 5x plus 6x. Well, that works because 5x plus 6x gives me 11x. 5 times 3 gives me 15, and x times 2x gives me 2x squared. So I grab the factorization. And the factorization is still going to be the product of two linear polynomials, x plus 3 times 2x plus 5. And here are my two linear polynomials. And notice the GCD of 2 and 5 is 1, so that can't be further. That's a prime, and that's a prime. X plus 3 is prime because it's a monic linear, it's a monic degree 1 polynomial. So the move to leading coefficient not equal to 1 was not as bad as we thought. Sometimes it can get worse, but we try to go easy on you as far as possibilities. Okay, so the next one is a polynomial in the variable n. Yeah, they like changing the polynomial, the variable, but that really shouldn't prove to be any difficulty for you, because after all, these are dummy variables. So we're trying to factor 2n squared minus 38n plus 80. So again, we're going to remember, let's take the GCF of 2, 38, and 80. And what do I know? I know that the GCF is either going to be 1, greater than or equal to 1, or less than or equal to 2. It will be 2 if 2 divides both of the larger numbers, and it does, because both of the larger numbers are even. So I'm going to transform this by factoring out a 2. So 2n squared divided by 2 is n squared. 38n divided by 2 is 19n. And 80 divided by 2 is 40. Now, isn't that nice? Because now, all I have to do is look at a monic polynomial in the variable n is what's left. So I can go back, and this will be a lot easier. I can discover whether it's prime or not much faster. When the leading coefficient is not 1, discovering whether it's prime or not can be exhaustive, because sometimes there's a lot of possibilities. So n squared, 40, and minus 19n. So these are polynomials in n, so just like before, I have to have an n there and an n there. N times n is n squared. Since this is negative and this is positive, both of these factors have to be negative. So I could try minus 1, minus 40, minus 2, minus 20, minus 4, minus 10, minus 5, minus 8. Let's start with that list and see what we get. Well, if I try minus 1 and minus 40, when I bring these down, I'm going to get minus n minus 40n, and that's going to be minus 41n, so that's not going to work. So let's erase those. If I try minus 2, whoops, I'm not done with the erasing yet. If I try minus 2 and minus 20, let's just do this in our head. If I try minus 2 and minus 20, then that gives me minus 2n minus 20n, and that's minus 22n, not minus 19n, so don't want that. Ooh, what did I do? Oh. Sometimes I worry about doing this because I've had the program crash on me, and I don't want to edit this one. So let's try minus 4 and minus 10. I don't think it's the program so much as the user, me. Minus 4, it could be the program, who knows. Minus 10, so that gives me minus 4n minus 10n, and that gives me minus 14n, and I want minus 19n. So that's not working. And then the last one, minus 5n, minus 5, and minus 8. So that gives me minus 5n, minus 8n, That gives me minus 13n. And I wanted minus 19n. So I've checked all of the factors. And none work. So this is as much as it can be factored. Now notice that when I say the polynomial is prime, I'm only talking about what's in parentheses. The original polynomial can be factored. The original polynomial can be factored because we were able to factor out the GCF. But once we factored out the GCF, then what remained, the Monic trinomial and the variable n, turned out to be prime. So it's not true to say that the original was prime, because the original could be factored. But that's as far as it can be factored, because the resulting trinomial and the variable n cannot be prime, cannot be factored, so it's prime. Okay. X squared minus 18x plus 17. We already did that, so let's just look at, that's a Monic polynomial. How did it get in there? I don't know. Maybe I mistyped it. Let's just do 3x squared minus x minus 4. So this is 3x squared minus 4 and minus x. So since the leading coefficient is prime, I have no real choice but to put x there and 3x there. Here this is negative and this is negative. So this is going to be the sum of two numbers, which is negative. So it means the larger of the two will have to be negative. And since this is negative, it has to be the product of two factors, exactly one of which is negative. Four times minus 1, or minus 1 times 4 is equal to 2 times minus 2, or minus 2 times 2. And that's our factorization. So it's going to come from these two lists. But here I can use, again, logic on logic, math on math. I know that since this is minus 4, I have to choose, and I'm adding two factors that is going to be negative, the larger of the two has to be negative. It's 4 and minus 1, and I should have just left the 4 there and attached the negative on the 4. I'm so used to talking about the law of commutativity and changing the factor order. So I want to use this choice because the larger of the two factors is negative. So I'm going to do 4 and minus 1. So that's going to give me 4x, 3x minus 1, minus 3x, and that's not going to work. 4x minus 3x gives me plus x. So let's try something different. So let's try this over here. Notice how what I have written up here is coming into play. The x, where the x and the 3 is. So this is where you're guessing and checking. Instead, I'm going to go ahead and I tried that one, it didn't work. So now let's do 4 and minus 1. So that's going to give me 4x minus 3x. Did I do that wrong? I'm getting deja vu. Didn't I just do that very one? So I used that one, not this one. So let's do minus 4 and 1. That's going to give me minus 4x plus 3x. And that gives me indeed minus x. So my factorization is right here. I don't know how many times students get this entire table filled out, but then they write down the wrong factorization. So you got to do the kitty corner thing. And it doesn't matter which direction you get, but you have to get the signs right. The x terms should always be positive, but the constant terms will sometimes have a negative. So we're going to do a little bit more complicated method in number 9, 10. Yeah, we've got quite a bit more to go. But before we leave number 8, I want to show you why this is working. So let's look at the general case. So let's multiply out two polynomials, ax plus b, linear or degree 1 polynomials, cx plus d. So that is going to be equal to a times c x squared plus plus a times d x plus b times c x plus b times d. So let's factor this. So here I have to have an ax and a cx, and that gives me ac x squared. Here I have to multiply two factors b and d that give me my constant term bd. And what is my term down here? It's AD plus BCX. So there's an X right here too. ADX plus BCX. So this is ABX plus CDX. So I have to rearrange them. I chose the wrong variable names, but you see that's how I produced the table. Here what I need to do, just to fix it, is to put D here and B here, and that's equal to B times D by commutativity. And then I have AD plus BC. I'll go ahead and write it in a better way for you. You all have completely turned off, haven't you? You don't even care how it works. Now I have ADX plus BCX. And that's what I have there, and that's what I have there. So how do I get the factorization? AX plus B CX plus D. So that's the engine underneath of all of this. Now look at this next one. You'll see something like this and you'll just like, I can't do that. But you can. because we always have to remember that very first step that sometimes I don't particularly remind us of. 12x cubed y minus 22x squared y plus 8xy. And you've been factoring polynomials in a single variable. What comes to our rescue is the reminder that we should factor out the GCF of all three terms. So 12x cubed y, 22x squared y, and 8xy. And if you take the GCF, that's the GCF of 12, 20, 22, and 8 times the GCF of x cubed and x squared times the GCF of y times y. Because the GCF of y and y and y is just y. So the GCF of 12, 22, and 8 is going to be, once you do your table, it's going to be 2. The GCF of x cubed and x squared, we take the lowest exponent times y. So we're going to factor out 2x squared y. So go ahead and try to factor out 2x squared y and see what you have. I did that wrong. There's an x there. Yeah. Ooh, I'm glad I caught that. I forgot to write right here that this last term has an x in it. And that will definitely make a difference. So the GCF now of x cubed, x squared, and x is just x. So our GCF is 2xy. So let's factor out 2xy. See what we have remaining. 12x cubed y divided by 2xy gives me 6x squared. Minus 22x squared y. Well, minus 22 divided by 2 is minus 11. X squared divided by x is x. Y divided by y is 1. Plus 8 divided by 2 is 4. Xy divided by xy is 1. So now all I have to do is factor. See if this can be factored. So it is something. It actually did reduce into something that we can factor, because now I have a degree 2 polynomial. Unfortunately, the leading coefficient here is not prime, nor is it 1. So when they're not prime and they're not 1, they require more work. If you get good about it, your brain has a way of finding patterns, and many times you can see the right answer. So 6x squared, constant term, middle term. So, 6x squared, for at least the top row, all we have to worry about is positive. That could be 3x times 2x, or 6x times x. And it doesn't really matter the order you put, because whatever order you do, you can change their effect by switching the order in the second row. Now 4, we're going to have negative factors here, maybe, because we're just going to have to check a lot of things. So to get a negative factor, one of these have to be negative, but 4 has to be positive. So I can do minus 4 and minus 1, or minus 2 and minus 2. So let's just do minus 2 and minus 2. So that's going to give me minus 6x minus 4x, and that's minus 10x. So that's not going to work. And there's no sense in changing the order of minus 2 and minus 2 because it's the same. Let's try minus 4 and minus 1. Minus 4 and minus 1. So that gives me minus 12x minus 2x. It gives me minus 14x. And I want minus 11x. So that's not going to work either. So let's do minus 1 and minus 4. So that's minus 3x minus 8x. Finally, I get what I want. So minus 3x minus 8x is minus 11x. And minus 1 times minus 4 is 4, and 3x times 2x is 6x squared. If that one had not have worked, I would have had to try a 6x and an x on the top. I would have had to try that possibility. But thank goodness that worked. So I get my factorization. So this is the entire factorization is 2xy. And in here, that turns out to be 3x minus 4 times 2x minus 1. And this whole kit and caboodle is the factorization. Oh, what are we supposed to do with this one? Well, this one's also going to be doable by just observing that we need to factor out the greatest common factor. So our problem is, we're always going to be pros at factoring after this. 18b to the 4th minus 57b cubed plus 30b squared. So I have to find out the GCF of my coefficients and then times the GCF of my variable terms. That's the easy part, right? The variable terms. b to the 4th, b to the 3rd, b squared. Well, this part right here is b squared. I take the smallest exponent. 18, 57, and 30. Well, 18 doesn't divide 30, so I know it's going to be greater than or equal to 1 and less than or equal to 18. Well, 18 is 3 times 6, and 3 divides 30. Does 3 divide 57? It sure does. So it's 19. So my GCF is 3. 3b squared. It cannot be 6 because 57 is clearly not divisible by 6. Why? Because 6 is even. So 3 divides 30. 3 divides 18. 3 divides 57, because, what did I just write? That 3 times 19? What did I, seriously, screw it, people. 57 divided by 3 is, yeah, it was 19. Why did that sound wrong to me? Anyway, the GCF is 3. So I'm going to factor out 3b squared. So 18 divided by 3 is 6. B to the 4th divided by b squared is b squared. Minus 57 divided by 3 is 19. B cubed divided by b squared is b. 30 divided by 3 is 10. B squared divided by b is 1. So now, all I have to do is see if this has a factorization. It may be prime. We don't know. That's the whole point. And you're really getting a workout on your factorization skills. So, and again, I'm telling you, you won't be able to finish this course, much less stand any chance at all in college algebra, if you don't learn how to factor. And I'm teaching you this, and of course you can always bookmark the video here for future reference, or look at your notes, because this, once you get it down, is a really fast way to do it. Now the problem here, for 6b squared, we have the possibility of 3b times 2b, or 6b times b. So let's go ahead and let's try the 3b and the 2b. For 10, since this is negative, both of these factors have to be negative. So for 10, I have minus 10 and minus 1, or minus 5 and minus 2. And of course, I may have to rearrange factors. So I'm looking for minus 19. Let's do minus 5 and minus 2. So that's going to give me minus 15b minus 4b. Great choice there. Because minus 15b minus 4b is minus 19b. Minus 5 times minus 2 is plus 10. And 3b times 2b, 6b squared. So this whole thing, all of these are equal. And 3b squared is equal to 3b squared times this degree 2 polynomial in the variable b is 3b squared times, let's get our factorization, so 3b minus 2, 2b minus 5. So all of this thing right here is equal to this right here. We're not going to worry with that one. I want to go on and do factoring by substitution. So we're used to referring to unknown real numbers by variables x or y, but we can also refer to unknown algebraic expressions like polynomials by other variables too. So for this one, we're going to factor 2a plus 3 cubed. So a plus 3 is our base, minus 5, a plus 3 minus 7, by substituting the variable w for the polynomial a plus 3. So let me just show you how that's going to work. Well, I've got to bring it back down to see what it is we're supposed to factor. So we're going to do 2a plus 3 squared minus 5 times a plus 3 minus 7. So this is example 12. Now here I'm going to do a variable substitution. A variable Substitution. And I'm just going to declare for the entire world, let, and you can choose your variable, but you don't want to choose A. Let W equal A plus 3. It might be a good idea to put it in parentheses only for pattern matching. So I'm going to rewrite this in terms of my new variable. Well, A plus, not 3, A plus 3 is right, but I wrote B. A plus 3, this right here. So A plus 3 is my base, and that's W. So A plus 3 squared is the same as W squared. And 5 times A plus 3 is the same thing as minus 5W plus 7. So now I have a polynomial in the variable W. My cat's right outside the window wanting in, but she's not going to get to come in because she just barely wanted to go out. You can't see her, she's on the other side of the screen. So, this is 2W squared. 7 is my constant term. That's kind of nice because 7's prime, and minus 5W. That should be a 2 squared. So I'm just going to put 2W and W there. I don't really have any choices here. The only choice I have is which of the cells I put a 2W in, but it doesn't matter. You've never seen me switch around these in order. Switching around in order can always be done with this one. And 7, since this is a negative, I'm going to have to do 7 as the product of two negatives, but 7 is prime. So my only choice is 1 times minus 7. But I do have a choice as to where I put them. So this is minus 2W minus 7W. And that's going to not work because that gives me minus 9W. So abandon that one. Surely this factors. Let me make sure I wrote this down right really fast. Yeah. Okay, I got it. I did write it down right. You kind of know that this one's going to factor. That's the whole point in giving you one that will. So now I could do, I already forgot what I did. Minus 7. Okay. Yeah, you all are screaming at me. Sorry. Yeah, because I knew it was not going to work and something was wrong. And I copied it down wrong. Isn't that a mess? That's supposed to be a negative right there. And yes, that will make all of the difference in the world. I was already thinking something's way wrong here. Okay, now I have different choices. So let's do that. I just turned that to either 1 times minus 7 or minus 7 times 1. So let's do minus 1 and 7. So that's minus 2W plus 7W. That gives me 5W, so I'm close. So let's change the signs. And now proceed. This gives me 2w minus 7w, and that gives me minus 5w. So I have my factorization. All I have to make sure is I get the grouping right. So this is equal to 2w minus 7 times w plus 1. But I'm not done, because my original polynomial is in A. So what I have to do next is replace w with a plus 3 in parentheses. It needs to be in parentheses because you're multiplying 2 times w. If you just put 2a plus 3, then you'd end up writing 2a plus 3 instead of 2a plus 6. So all I'm doing right here is replacing w. Here it doesn't matter if it's in parentheses or not, because nothing's multiplying w. So let's simplify. 2 times a is 2a. 2 times 3 is plus 6, minus 7. A plus 3 plus 1 is a plus 4. So it finally simplifies down to 2a minus 1 times a plus 4. Wow, we did it. So one last one maybe? Yeah. We'll just do one of these. We'll do number 13 and we'll call it quits. I mean, we've done a lot of factoring here. So the problem here is the GCF is equal to 1. The 42 is a constant term. But the same type of trick is going to work. We're going to do a substitution, and then we're going to back substitute it back in. So 5x to the 4th plus 29x squared minus 42. Notice that the GCF of those three terms, the GCF of 5x to the 4th, 29x squared, and 42 is equal to 1. So I can't fix this by factoring out the GCF like we've been able to do in the past. But I can make a substitution. If this were a degree 2 polynomial, then I could use my techniques. These techniques work for trinomials, degree 2 trinomials. So let's do that trick again. Let's let w equal x squared. Then w squared is equal to x squared squared, which is x to the 4th. And I got everything I need. So that means I can rewrite 5, well, x to the 4th is w squared, plus 29, x squared is w, minus 42. Now you don't have to choose w, I just choose w. I don't really want to choose y. So now all we have to do is factor this polynomial in w, and then when we're done, we replace w back by x squared. So all we have to do is factor So that's 5w squared. I'm always happy to see that the leading coefficient is prime. Indeed, noticing the many different times that the leading coefficient on the degree 2 term is prime is what caused me to change my preferred method of factorization to this method. So since that's 5, I only have one choice. 5w and w. Down here, this is negative, so exactly one of the factors have to be negative. So minus 42 is equal to minus 7 times 6. It's equal to minus 2 times 21. Let's just try those two. Let's try minus 7 there and 6 here. So 6 times minus 7 is minus 42. So that's 5w times 6. That's 30w minus 7w. That's not going to do it. So we got to try something else. So let's try 7 minus 6. That's not going to work either. That's going to give me 35w minus 6w. Let's try 6 minus 7. Did I do that already? You really need a good, system to keep your track. So that's going to be minus 30w plus 7w. That's not going to work. So let's do 2 minus 21. That's minus 21w plus 10w. That's not working either. So let's try 7 and minus 6. That's minus 30w. Did I write everything down right? 5w squared plus 29w minus 42. Not going to work either. This is one you just hate. Try 7 here and minus 6 here. So 5w times 7. Yeah, we haven't tried that one. That's 35w. And w times minus 6 is minus 6w. Finally, we get it. 35w minus 6w is 29w. I really should have started. In this case, what you have to do with these, which is hard, you have to have some kind of housekeeping or bookkeeping that will keep track of everything you've tried. And I lost track really fast. Did you notice that? So that's in terms of w. But I have to go back, and my original is in terms of x. So w is equal to x squared. So wherever I see the w, I just replace it by x squared. And we're done. So it's 5x squared minus 6 times x squared plus 7. So that's all we're going to do for this lecture. And so really good workout on factorization. Start with the Monic Trinomials. the ones with the leading coefficient of 1, and then move your way up.